We will continue to talk about adding features, for example, those that allow for integration with the device through APIs. Mobile device applications will have to integrate with the physical and logical resources of the device. In sum, GeneXus will give us a set of APIs, in the form of external objects, to add various features to the mobile application and, in particular, to make integration possible with other applications and device features. All the APIs, SDTs, and procedures required by these APIs are in the GeneXus module, below the References node. Remember what we said at the beginning of the course when we created the KB from scratch. This module, together with its submodules, comes with the KB and all its objects already compiled. That's why they're read-only. For this reason, they don't have to be regenerated every time the application is built, which greatly reduces compilation times. The same will happen with the predefined domains. In addition, anyone can develop a module with external objects, procedures, SDTs to implement SD and web features and distribute it. In this way, we will be able to import these modules and use them just like predefined APIs. As a result, collaborative work is simplified. At first sight, we can see some special APIs for SD, APIs for the web. Along with others that can be used for either platform. For example, the common submodule contains the Geolocation API. The UI submodule, user interface, contains the navigation external object that will allow us to show or hide regions of the screen. In the social module, we will find APIs to interoperate with Facebook and Twitter, as well as to share information with one of the programs installed on the device. For example, here we want the user to be able to share the description and date of the session he's viewing through one of the apps installed on this device. He may decide to share it via WhatsApp, Facebook, Twitter, email, and so on. How is it implemented? By adding a Share button in the Session, General, application bar of Work With Sessions. It's displayed here, and we program the associated event by calling the Share Text method offered by the API called Share, which is here to the left. Let's see it in GeneXus. First, note that since there are only 3 buttons, there's enough space for the application bar to appear. That's why the Share icon is shown. Let's see it in GeneXus using my device. Here we're in the Session transaction in Work With for Smart Devices, Sessions General of Delete. This is the Share button, and if we open the programming of the associated event, we see that it's calling the Share external object, which can be found below the References node. Social subnode. If we expand here, we can see these 3 APIs, external objects. We open Share and see that the first one offered is read-only, and then these 2 methods. We will use the first one, Share Text, sending these 3 parameters displayed here. Let's see it in GeneXus. My device is connected, so we display the sessions and select one. As we can see, there's a group of actions. The first of which is Share. If I choose it now, it offers all the programs installed to share the information of that session. So I will return without sharing. Here are 2 more actions offered in that menu. One of them allows tweeting the session's information, and the other one allows marking that session in my device calendar. If I choose to tweet, I'm offered to type a message directly on Twitter. The Twitter app is opened with the details of the session we sent, including its description and the GeneXus hashtag, as well as the time. As we said before, another option was to add the session to my calendar. Note that the calendar app on my device is open to schedule the session. As for Twitter, we added the tweet button, to which we associate the tweet post event displayed here. And we invoke the Twitter External Object API, tweet method. Note that there are two possible methods to call tweets with the same name, but which are different in terms of the number of parameters we send to them. In this case, only one parameter, that is the text we want to display when the Twitter application is open for the user to use this text or customize it. In addition, we also have the Calendar API, which has only one method, schedule, that we're using here. In the event associated with the schedule button sending the information, the parameters required by the method. We must send all the parameters in the order in which they are included in the method. If there is a parameter whose data we don't have, we leave the place empty for that parameter, but we type it in the invocation itself. One API that had appeared before, but we hadn't paid attention to, is the Actions API, which allows, among other things, abstracting functionalities like login, save, and cancel. They're methods that we had already seen in the events automatically implemented by the work with pattern at the detail level, as we can see on the screen. For example, let's see the speaker's detail general section. We have the update and delete buttons for the view mode. For the edit mode, we have save and cancel. In its programming, note that the save event, which corresponds to the case when we're editing a speaker's information and we want to save that information in the database, it uses the save method of the Actions API. The save method of this API encapsulates the invocation to the corresponding business component that effectively makes the insertion into the database. Remember that this is a REST service, an API exposed by our application. Next, with return, it returns to the caller. Let's ask ourselves, why doesn't the invocation only include action.save? Why is genexus.sd.action.save shown? Remember that they are modules. And the thing about modules is that the objects inside them are visible from the module. However, there may be other modules inside the same KB with objects that have the same name. They are other objects, so the way to disambiguate it and indicate which external object action I'm calling is through the module path information. This will be necessary depending on whether there are other objects with other names. That's why in the previous steps, when we had to program it, we didn't enter the entire path to the calendar external object. We called this object directly. We also note that the cancel event uses the method with the same name as the API. This was all done in a predetermined manner. In GeneXus, note that we're in the general section of the session. In the PPTs, we talked about speakers, but it's the same. We have update and delete for the view mode, and for the edit mode, we have the save and cancel buttons. The events were programmed in a single screen, and we could vary them. We had two different layouts, but the event screen is the same. That's why the four of them are programmed here, and we see the invocations, which were described in the PPTs. In addition, we see this composite block in Composite, which we will see in the next class. We can already mention that it's a required block. Every time we need to type more than one command line within a client event. Suppose now that from the list of speakers, we want that after inserting a new speaker in the database, it's also added as a contact in the Device Contacts app. To do so, after invoking the detail in insert mode, when the user clicks here to validate all the information he entered, it will return to the caller, which was the event associated with that button. What we want to do there is open the Contacts application to enter the information of the speaker that has just been added to that contact list. Next, we will have to use the Contacts API that comes with GeneXus. In particular, we will use the addContact method to add a new contact, to which we must send this series of parameters. If we don't have some of this data, we send the empty string and invoke it as we said with the object name, and the method too. How do we retrieve this data? The data that must be sent to the method to be sent to the API. Remember that first we're calling work with devices, speakers detail in insert mode, once we're positioned on that object. So we call this panel. The user will enter all the data and will return. We need to have a way to retrieve the data entered by the user to send to the Contacts API. Remember that insert offered two options. The first one was not to send any parameters, and the second was to send a single parameter of the business component data type associated with the level in which the insertion is to be made. This business component will allow us to initialize the values on the screen we're invoking. Remember that from here, we're invoking this screen, sending this business component. In this case, if before sending it we initialize some of these values, when calling the screen, the values will come already initialized. The user will simply have to insert the missing ones or change them. In addition, when the information is confirmed from this screen and returns to the caller, this business component will come loaded with all the information entered by the user. That's the way in which we have to obtain all the data to be sent to the addContact method. Now let's see it implemented in GeneXus. We open the speaker transaction in insert mode. In the list level, we see the event. Here is where the predefined invocation to the detail in insert mode is programmed. We've created a speakers variable of business component data type. So as not to see everything done, we will invoke an API and one of its methods. Since GeneXus offers help to enter the various parameters, contact in this case, we find it here in reference mode. So, for example, we drag the name if we don't remember it exactly and with a period. Note that we're offered all the methods available, that external object. In that case, we select Add Contacts, and note how we're offered information about each parameter to be inserted each time. The method will also return a Boolean value that may or may not be used. We can omit this because we've already done it. Now we try in GeneXus what happens when we run the insert to add a new speaker to the application. In the device application, we add a new speaker. Note that the screen is empty, without any data. I'll add myself as a speaker, Cecilia Fernandez. I'm asked to enter a photo, which I won't enter. I may choose a photo from the image gallery, or I could take one. The country is necessary. If it isn't a foreign key, it won't let me save. We will only add the phone. Let's see what happens when I tap on Confirm. Note that the Contacts application is open for me to create a new contact, and that the information sent with the phone is displayed. If we save, this contact will be effectively saved. In addition, the new speaker is shown without a photo because I didn't add it in the list. Another API that will be frequently used is the Interop API that can be seen on the left. It offers interoperability with the messaging app and allows sending emails and SMS, as well as showing messages to the user to notify him or to request information, run videos or audio files, and so on. In this example, we might ask the user, before opening the Contacts app, to confirm that he wants to add this speaker as a contact. Note that because the confirm method will be used very frequently, we will not need to type interop.confirm. We only type confirm, and GeneXus understands it. Let's try this in GeneXus. After the invocation to the detail, and before the invocation to the add contact method, we can drag interop period and choose the confirm method. Alternatively, as we said, we can simply type confirm. Here's the text we want to display to the user. So let's try it. If I were using live editing, I could try this on the device without running it first. Since it was disabled, I will do it. There are some more APIs. For example, one of them allows us to know if there's a connection with the server at a given moment, as well as the type of connection. Another one, client information, obtains information about the device running the application, its ID, operating system, version, language, and device type. Others play audio and playlists, interact with the device camera, take a photo, or start recording a video, interact with the photo library, and so on. For example, one that is widely used allows working with the geographic location. We already used the geolocation semantic domain when we wanted to show the restaurants, not as a standard list, but as points on a map. To do so, we only had to change the control type of the grid to SD maps. In our application, we've implemented the list of restaurants, which corresponds to the Work With node, where the grid has the default control type. In addition, we will offer the user the possibility to enter the time available for lunch, and then we'll show the restaurants that commit to serve customers within that time period. This is a panel that we're viewing on the right, and whose layout is very similar to that of the list of the Work With. The grid will be displayed differently this time, as points on a map, because of the restaurant geolocation attribute. This is achieved by receiving, through a parameter in that panel we mentioned, the service time, and then filtering the grid that will be displayed as SD maps according to the attribute restaurant quickest service time which records the maximum time in which the restaurant commits to serving customers. If we set it in GeneXus, here in the restaurant transaction, in the work with, we have the node in the list of the action bar, the map button. We will see the associated event and that we have programmed the invocation. This will be seen later, so we don't have to pay too much attention to it now, the call option. What's more, we can call this restaurant filter panel, to which we have sent the two parameters, time and OK. We open this panel, open the layout, and we see that there are two variables, two output parameters that will return loaded to the caller. If we open the layout, we see that the user will enter the maximum time he has available for lunch. When he clicks on OK, in the events, this OK variable will be loaded as true, indicating that the user has effectively entered a value. It returns to the caller, and pressing cancel sets it to false, and also returns to the caller. If we select the restaurant once again, we can see that if the user didn't cancel the operation, we will invoke a panel for smart devices. We open it, Restaurant Maps, which, as we can see, is a grid containing the restaurant image and name. It'll show that information, and in its properties, we have in control type SD Maps location attribute Restaurant Geolocation. In Restaurant, we look at its structure, as well as the time in which this restaurant commits to serve customers. So we return here, and since it has received that maximum time in a parameter, if we go to the Group Data section of the grid, we see that the conditions are programmed here. This condition establishes that the time must be lower than or equal to the time entered by the user. So, only the restaurants that meet this condition will be loaded and displayed as points on the map. To test it in GeneXus, we select Run. We open the restaurants, and there we choose the Maps option. Note that the intermediate panel is opened to ask for the maximum time available for lunch. Suppose that it's 90 minutes, so we click on OK here. This other panel is then opened with the restaurants that meet the desired condition as points on the map. Now we may only want to show the user the restaurants located within a certain distance from the device's location. This is where the Geolocation API comes into play, offering methods to, for example, obtain the current geolocation, for which it needs the device GPS, track the device path through time, end the tracking, obtain the latitude or longitude from a geolocation, as well as obtain the distance between 2 points, an address from a geolocation, or vice versa, configure or obtain proximity alerts, and so on. Therefore, to show only the restaurants at less than, let's say, 400 meters from the current location of our device, we will have to use the getDistance method and the getMyLocation method. We will use both of them in the grid when filtering the information displayed. This is exactly what an application does to obtain the ATMs nearest to our location, as we can see on the screens. Another frequently used feature is notifications, which can be sent from the web server to the various devices that have our mobile application installed, even when it's not running. In this way, the user will receive the notification sent by the server and will be able to perform the corresponding action. To this end, we will have a notification module with all these APIs we're viewing. Here, we've introduced only some of the various APIs available for smart devices. In addition, remember that we can also work collaboratively by creating our own modules and external objects and sharing them with the community. To learn more about all the APIs available, we recommend visiting our wiki. Now, let's move on to the next topic.